Okay. Okay, please go to that web page. That is. So go to my class, my personal page. Okay, this one. Chatting, chat. Okay. Here, that is a link. Okay. Then scroll it down. Then you can find the link to computer architecture class page. This one. This is the one. COSE 222, right? Computer architecture. Okay. Click on this. It will ask you some credential, right? So ID is COSE 222. Okay. And password, the same, right? The my lab name ESCA. Okay, ESCA. Then you can log on to the class page. Okay. So I'm going to post all the lecture slide and the homework assignment, class project announcement, everything. Everything will be here. Okay. So this is the place you have to live with. Okay. So how can I? It's annoying. Okay. Okay. So today is the first day. So I'm going to give you an overview of what we are going to achieve throughout this semester. I already posted, by the way. I already posted all the lecture slide here. You can click on this course info, course intro. Okay, the first PowerPoint. I really want to see you in the classroom this semester, but this pandemic is very tenacious, right? It doesn't go away easy. So probably we have to stay online until midterm exam, right? Afterwards, we'll see how it goes, right? Okay. So anyway, we have to stay online. Okay. So this is okay. First course introduction. I'm Professor Sotewon, teaching this course, instructor, and we are going to use this one as our textbook. Okay, I wrote this book. I wrote this book just now, and it is being baked. Okay, it is being printed now. So the book will be available next week in the bookstore. You cannot purchase this week. It will be available next week. The problem is this book is written in Korean. Okay, I'm trying to explain computer architecture in a very friendly and easy way. So I think the second year college student like you, this book will help you a lot. The problem is because it is written in Korean. If you are not familiar with Korean, then you have option, right? You can use either this one, digital design and computer architecture, or this one, computer organization and design. Okay. And in this class, we are going to talk about 32-bit, the CPU, central processing unit, 32-bit. Okay. Probably you don't know what do you mean by 32-bit, right? But don't worry about that for now. We will get to that. I'm going to explain in detail about this 32-bit architecture. But the thing is, this book, the book I wrote, it is based on 32-bit architecture, 32-bit CPU, and this reference, second reference, this one, computer organization and design, that is based on 64-bit CPU. So a little bit different, okay? But in the first book just came out. Look at this year, 2021. It just came out. So actually, I haven't purchased this book. I didn't have a chance to look at this book, but if you go to Amazon web page, this one, okay, digital design, computer architecture, it is providing some sample pages, okay, like this. And by looking at these sample pages, it says RB32I, right? RB32I. That means 32-bit architecture, 32-bit. Okay. So again, if you are not familiar with Korean, probably you want to use this book, Digital Design and Computer Architecture. Okay. Any question about this textbook? All right, chatting. I need to open chatting. Okay. Okay, then there are prerequisite. I assume you have taken these two courses. The first one, digital logic design. Okay, and I assume you are familiar with C programming as well. Okay, and class hour. I don't I don't want to set up specific office hour because right, no one is going to show up even though I set up office hour, right? So instead, you can ask questions after class, or you can come to my office. Okay, I usually stay in my office, during weekdays. So you can come to my office, send me an email first, then you can make an appointment. Okay, that is a class page, right? Like our class page and contact information. Okay, my email address. Okay, we have teaching assistant, Sangwon. Sangwon, can you introduce yourself?
Hello everyone, my name is Sangwon Shin, majoring computer security in ESC lab, and I'm a teaching assistant of this course. So if you have any question, just feel free to ask through my email, which is on this slide. Then I will try to reply as fast as I can. And that's it. Thank you.
Okay. Okay, thanks. Okay, so Sangwon is going to help you a lot. The Sangwon is going to grade your assignment. Okay, if you go to our class page, Sangwon is going to do all the grading of assignment. So assignment like this, and also class project. Okay, there is a class project, assignment and class project. Okay, so Sangwon has all the power. Okay, so use him. Okay, use him. Smart. Okay. Okay. So your computer. This computer architecture class is for second-year college students like you guys, right? So that means you have spent 1.5 years as a computer science major. And what are you doing? What are you doing with your computer? Okay. Probably, the main reason you want to use computer is to surf the web, right? Sometimes you use computer to cook up some documentation, and also you listen to music and watch, movies, and you are doing a lot of SNS, okay? And sometimes you are addicted to the gaming, right? The question is, how is that possible? Computer is one physical device. Think about your notebook computer, desktop computer. It is just one physical device, right? And your computer, that device it has many different shapes depending on the program you run, right? If you run the Chrome, then your computer turns into web browser. If you run HWP or MS Word, then your computer turns into documentation tool, right? And then you are doing SNS. Sometimes your computer turns into this gaming console, right? So how is that possible? Right? The secret is what? Secret, you all know, right? Secret is depending on the program you run, computer can do many different tasks, like this, right? And how is that possible, right? How is that possible? Depending on the program, computer has many different shapes, right? How does your computer execute your program? Okay, that is the question we are going to answer throughout this semester. One physical device, right? Your computer, one physical device, but depending on the program you run, right? Depending on the programs you run, Google Chrome, right? And MP3 player and SNS, some gaming console, right? Depending on the program you run, it has many different shapes. How is this computer able to execute this program? How does this computer execute all these different kinds of programs, right? That is the question we are going to answer. Okay, that is going to answer. Okay, so I prepared this slide to give you some motivations, why you have to study computer architecture. That is the computer advertisement, a little bit old computer advertisement. But when you purchase computer, you look at this, computer ads, right? And figure out, buy this computer or not, right? But, look at this, computer ads and how many terminologies do you understand from this, computer ad? Look at this. It says what? It says 2.0 gigahertz. Okay, some nice number, right? You don't know for sure what it is, but it's a nice number, right? And 2 megabyte level 2 cache, level 2 cache, okay? And it is a little bit old computer, so it is using 800 megahertz front side bus. How many jargons do you understand from this computer ad? Probably nothing, right? Nothing. You don't understand anything, right? But somehow you purchase computer, right? So you go to electronic store, right? You go to electronic store in Yongsan. Then the salesperson is trying to explain, okay, what this means, what this 2 megabyte level 2 cache means. Okay, you know what? Actually, they don't know. The sales guys don't know about this, the meaning of this, terminology. They are saying what they are trained. Okay, they are just saying what they are memorized, what they memorized, right? And sellers like you also don't know, right? Okay, what is 2 gigahertz? It sounds like a nice number, but don't know for sure, okay, what it means. Okay, so the thing is, sellers, buyers don't know anything about these terminologies. But the strange thing is, there's always a deal. Nobody knows, okay, these terminologies, but there's a deal. That is very strange, right? Very strange market. What do you think? Don't you think so? Mingyu, what does this mean? 2 gigahertz.
Oh,
What does that mean? What does that mean? This 2 gigahertz? So this number? That is called frequency. How fast CPU is running, right? How fast? Okay, but you don't know, right? You don't know the meaning of this number, but you think it is very nice number, right? Nice and attractive, okay, and lovely, right? So somehow you purchase computer, right? So after taking this class, you are going to understand these jargons. That is not the purpose. Understanding these jargons is not the purpose, but as a byproduct, we'll know, okay, the meaning of these jargons. Okay. Okay, don't worry too much about this. I'll get to that. I'll explain everything to you. Okay. So look at this computer advertisement. It says, some advanced, terminology like this. It says It says this CPU is built with 40 nanometer 공정 technology. It says it is built with this semiconductor technology. What do you mean by that? What do you mean by this? 40, nanometer technology. It is very, technical terminology. I think I'm pretty sure 99% of the people don't know about this, the meaning of this terminology. But computer, sellers, put those numbers because I don't know, it sounds like nice and attractive. That's why, right? Okay, so they are, they are, pulling you guys, right? Because nobody understand these jargons. If they put these numbers, some technical terms, then people think it is nice, performance is better, right? The same thing goes to here. So the computer advertisement is actually wrong. It is not quad core, dual core. So they put anything, okay, because no one is understanding, right? So very strange market. Okay, let me introduce very important terminology to see a big picture when you study computer, not only computer architecture, some subject in any technical field. Okay, the abstraction. Okay, this one, Chanu, can you please read this for me?
Abstraction helps us deal with complexity, hide lower level detail.
Okay, what is abstraction in Korean, Chanu?
I guess. Is it right?
추상화, right? 추상화, right? Abstraction is 추상화 in Korean, right? So what do you mean by that? Abstraction, 추상화. It is still murky and vague concept, I guess, right? So I prepared, very, intuitive analogies to show you, to explain, abstraction. These two are, combustion engine, and this one is brake system, car. Combustion engine, car, and brake system. It is very complex mechanical device. How many of you do have driver's license? How many of you? Some of you, right? And how many of you understand the machine detail, how combustion engine works, how brake system works? How many of you? Probably no one, right? No one understand how this engine works. Okay, how brake system works. Then the question is, how come you can drive a car without understanding this machine detail? So because car is providing abstraction layer. This car cabin is abstraction layer. Okay. So what it says is, okay, don't worry about this. Don't worry about this machine detail. It's too complicated. Okay. So what you have to do is, if you want to move forward, you shift this gear to the driving position, then step on accelerator. Then car will move forward. Right. If you want to turn left or right, use this steering wheel. Right. So this cabin is providing abstraction layer. So what it says again, don't worry about this machine detail. Okay, don't worry, forget about this. If you understand this, this steering wheel and gear shift, then you can drive a car, right? So anyone can drive a car. So abstraction layer. Okay. So another example is that is digital logic, hardware system inside the vending machine. And how many of you understand how this hardware system works? Probably many of you, because you have taken digital logic design course last semester, right? where you studied how to design vending machine logic, right? But the most of the people, okay, public people, don't understand how this hardware system works. Nevertheless, they are able to take out Coke, Sprite, right? How come? Because this box is providing abstraction layer. Okay, so what this box is saying, don't worry about this machine detail, digital logic detail, too complicated. What you have to do, insert coins and press the button. That's what you have to do. So this box is providing abstraction layer. So anyone can take out Coke, okay, insert the coin and press the button. Okay, abstraction layer. And computer is also built based on abstraction layer. If you open this, desktop computer, the most important component inside this computer is called CPU. CPU, or many different names, several different names. So most important component inside the CPU is called central processing unit, CPU, or some people say processor, CPU or processor. Okay. And this is super complicated hardware component. Super complicated, really very complicated. Do you know how many people work for Intel? This chip is from Intel, right? US company, Intel. Intel is designing and manufacturing, this chip. Do you know how many people work for Intel worldwide? Roughly 100,000 people worldwide. Okay. Of course, there are many different departments in Intel, right? Marketing department, sales department, human resources, research department, design department. Okay, there are many different departments, but all these people are there to research this chip, design this chip, and promote this chip, and manufacture these chips, and so on. Right? There are so many people, so it is very super complicated chip. Okay, so because so complicated, Intel is providing abstraction layer that is called instruction. This ones and zeros. This ones and zeros. So the thing is instruction. In Korean, 명령어. Instruction. ISTRU. Okay, instruction. Okay. In Korean, 명령어. You know what? The program, right? I told you program, right? Google Chrome, MP3 player, movie theater, the documentation tool, everything, right? Program. Each program is a collection of this collection. Okay. So program is composed of many different instructions and also data. Construction plus data. Collection of instruction and data. That is program. That is software. Okay. So instruction. Okay. These ones and zeros are instructions and data. Instructions and data. So if you understand this instruction Intel is providing, you can fully manipulate. This chip. Okay, you can do whatever you want to do with this chip if you understand instruction. But look at this ones and zeros. If you look at this, ones and zeros for 1 minute, your eyes are spinning, right? Your brain stops. You don't want to look at this, right? So that is why computer is providing another abstraction layer that is called operating system. Windows, right? With nice, GUI environment, Linux, right? Nice environment, right? So if you put the computer, okay, a very nice graphical user interface appears, then your job is what? Your job is, look at this. Your job is Just click on this. Click on this, icon. Click on this, icon. Then you can surf the web. Right. So this abstraction layer is providing very convenient environment for you. So anyone can use computer. So again, what this layer says, okay, don't worry about these ones and zeros. Don't worry about these ones and zeros. Don't worry about this digital logic detail. Too complicated. Forget about this. Okay, your job, just click on icon, then do whatever you want to do. Okay, that is abstraction layer. Okay, and on top of that, on top of this operating system, you are writing application program, compile program, and run your program. Okay, that is computer hierarchy or abstraction layer. In this class, in this computer architecture class, we are interested in these two layers. Okay, so we are going to study, you are going to study instructions. Instructions, CPU is providing. And we are going to study one specific CPU. There are several, actually many CPUs in the world, like Intel x86, and smartphone CPU, ARM, and MIPS, and some Hitachi processor, and so many different processors. And the thing we are going to study is called RISC-V. We are going to study RISC-V CPU in this class. Okay, and to studying RISC-V CPU means you have to learn the instructions. Instructions is CPU. Instructions, this is CPU is providing. What kind of instruction RISC-V is providing? Okay, that is going to that will be the first thing we are going to study. Then I'm going to show you how to design CPU. How to design CPU so that that CPU is able to execute instructions. Okay, this guy is providing. Again, I think roughly 4 weeks. We are going to spend roughly 4 weeks studying RISC-V instructions. Okay, RISC-V instructions. Then afterwards, I'm going to explain how to design digital logic, how to design CPU, in other words, so that that CPU can execute the instructions we studied. Okay. So it is simple. So thing is, so we eventually in this class we eventually understand CPU. Okay. Okay. CPU is also can build with digital logic. Okay, and CPU takes instruction. CPU is taking instruction as an input. So taking this one as an input and execute it. Okay, so we are going to study. Okay, we are going to spend roughly 4 weeks understanding RISC-V instructions. RISC-V instructions. Then later on, I'm going to show you how to design CPU so that that CPU can execute that instruction. Okay. So here, okay, to design CPU, you have to have some background, right? Digital logic, some digital logic detail, right? How about smartphone world? If you open this box, this package, then you can see. So brain of this smartphone is called application processor. Smartphone is using a little bit different terminology. instead of using this terminology, smartphone said instead of using CPU, smartphone is using this terminology, AP, application processor, okay, AP. Okay, so that is the brain. That is the brain of a smartphone. Okay, and inside this this chip, there are several CPUs, actually several CPUs, and also this is a huge, very complicated and device. Okay, so it is, because so complicated, it is providing abstraction layer. Okay, that is also same thing. It is instruction. Okay. Again, application processor is providing abstraction layer that is called also instruction. More specifically, is Apple application processor has ARM CPU inside, ARM CPU. Different kinds of CPU, ARM CPU. Okay, ARM is providing their own instructions, like addition instruction, subtraction instruction, and so on. Okay, again, we are going to study RISC-V CPU. It is also providing its own instructions, a little bit different shapes, but like addition instruction, subtraction instruction, and so on. So depending on CPU, the instructions are a little bit different. Okay, instructions are a little bit different. So ARM CPU is providing instructions, but instructions are also very complicated. Okay, so very complicated. So smartphone is providing next the abstraction layer that is called Android or iOS, right? So what it says is, okay, don't worry about this machine code. Sorry, don't worry about this instruction. Sometimes we says machine code or instruction. Don't worry about this instruction. Don't worry about this hardware detail. Okay, it's too complicated. Okay, your job. Okay, click on this icon. Then do whatever you want to do. Okay, I'm going to take care of everything. Don't worry about this. Okay. So that is abstraction layer, and on top of that, you are learning many different applications. Okay, that is hierarchy. Computer hierarchy in smartphone. Also abstraction layer in smartphone. Again, in this class, we are interested in these two layers. Okay, instruction and implementation. Okay, hardware implementation. Okay, let's take a look at general purpose computer system. Desktop system or notebook computer. Okay, so that is a motherboard or main board in computer. Okay, and it has many different components, but the main component in this main board is CPU and memory and these green boxes, I/O devices. Computer or computer system. Computer system is composed of three big components. First one is CPU, central processing unit, a brain of computer. Okay, it is doing all different kinds of processing, data addition, subtraction, multiplication, division, many different kinds of processing. Also, a second component is called memory. So memory stores your program, right? Your program, CPU, we have CPU, then memory, right? So memory has your program stored, your program, right? Again, the program is what? Program is collection of instruction and data, right? So it stores instructions and data. Okay. So memory stores your program. CPU is reading instruction, reading data, and do some processing. That is a big picture. Okay. So that is the second component. And the last component is I/O devices, all different kinds of I/O devices. Okay, like keyboard, mouse, right? USB, right? Wi-Fi module, right? And Bluetooth, right? Monitor, everything, right? So those are I/O devices. Computer, again, computer is composed of CPU, memory, and many kinds of I/O devices. That is computer. That is also smartphone. Smartphone is also computer. Okay. So take a look at CPU, motherboard. We have CPU, memory, and these green boxes. Green boxes are all different kinds of I/O devices. And this big component, North bridge, South bridge, it is also very complicated hardware component. But the main function of this North and South bridge, it is communication medium to connect what? CPU to I/O device, CPU to graphics card, CPU to hard disk, CPU to USB, CPU to some PCI Express, something and so on. Again, very complex, but you can just ignore. You can just ignore this chipset. Okay, North and South bridge, that is called chipset, these two. But you can ignore these two. So CPU, computer, again, CPU, memory, and all I/O devices. Okay, that is computer. Okay. And in this class, we are going to focus on these two components, CPU, the brain, okay? How this CPU is operating, okay? How this computer CPU is operating, and what kind of memory component you have in a computer. There is two big, topics we are going to study. Again, the first one is CPU. That is we are going to spend roughly, I think, 10 weeks, I think. 10 weeks talking about this CPU, instruction and hardware implementation. And the remaining 4 to 5 weeks, we are going to talk about a memory component, main memory, hard disk, and also memory component inside this processor, which is called cache. Cache. So cache, main memory, and a hard disk. So those are memory component. Also, register. Okay, register inside CPU. So those are memory component. Okay, inside the computer. We call memory hierarchy. Why do you want to have, these different memory components in a computer? Given that hard disk, right? Hard disk has everything. Hard disk stores everything. Why do you have to have main memory? Why do you have to have cache? And why do you have to have register? Okay. So we will talk about that. Okay. The reason why we talk about these two big topics is because that will affect performance, computer performance a lot. That determines computer performance. This memory hierarchy and CPU architecture, that will determine the performance of the computer. That is why we talk these two topics. Okay, and we are not going to talk about these I/O devices. We simply don't have enough time. We simply don't have enough time to talk about those I/O devices. If you want to study the detailed operation of I/O devices, you can take the class offered next semester. Okay, computer systems design, right? COSE 321. So I'm teaching that course next semester. If you go to my webpage, so course 321, computer systems design. Right? So in this class, we will talk a lot about I/O devices. Okay. So again, computer architecture class, because we have only 16 weeks. Okay, we will focus on CPU and memory hierarchy in computer. Okay. Okay, and computer system is evolving at at a very faster pace. It is 10 years old, more than 10 years old computer system structure. Okay, but if you purchase computer today, these two, CPU and North Bridge, these two are merged into one chip because of semiconductor technology, 반도체 기술, right? Semiconductor technology allows you to integrate, merge these two chips into one. Okay, so if you purchase computer today, then it looks like this. That is how old? I think roughly 4 years old, 5 years old computer. Okay? So look at this, 7th generation Intel processor, and you have one chipset. So that is CPU. Okay, this one is CPU and main memory. So DDR4, that is main memory. And the other component, all these components are I/O devices. Okay, so that is the main board of desktop or notebook computer. Okay, so that is a big picture. Okay, so this one, 조혜민, can you please read this sentence for me?
Yeah, the ultimate goal is to understand how your computer works really.
Yeah, so that is the final goal of this class. How computer works, how your computer execute your program. How come, right? That is the question. That is the question we are going to answer, right, in detail. Okay. Okay. This one, Yunsu, can you please?
So, to compare digital logic and computer architecture, course 221 is digital logic design. There we learned digital logic and what you can do with it. So we learned combinational logic design, composed 7-segment logic multiplexer, 18. And sequential logic design was composed of vending machine logic and digital clock logic. And there says what you have designed does not provide any programmability to users. And this lecture, computer architecture, we study and design computers, focusing on CPU. And processor provides programmability to users.
Okay, so this slide, thanks. This slide trying to compare, these two courses. This, I assume you have taken this one, digital logic design, okay, last semester. So what is the difference between, these two? Some simple digital logic versus, CPU. Because, the thing is, CPU is built with a digital logic. Same technique. When you design, vending machine logic, when you design digital, clock, okay, what did you do? What did you do to design, vending machine logic or digital watch? You have studied combinational logic, right? You have studied this one, combinational logic and sequential logic. Okay, that is a basic, principle, right? So based on these two, combination logic, sequential logic, okay, you can design anything you want. So you can design, the digital logic inside the vending machine, digital watch, right? So combination logic, what is combination logic? Remember? What is combination logic? You are brainwashed, right? No one understand, right? During summer vacation, right? You forgot, everything, right? Don't remember anything, right? Okay, it is very simple concept. Combination logic, output. So you are designing some, digital logic, combination logic. This output is determined based on, current input, current now, right? You apply some input, then output is determined based on this current input. That is combination logic, like this, right? This AND gate, right? Simple. Okay, so so let's say some button is connected, some push button is connected here. So if you push, then probably you are applying logic level 1. Then output is 1. So output is determined based on this current input. You push the button, then output is determined, right? So that is combination logic. How about sequential logic? Sequential logic, that is, output, sequential logic, 순차회로, right? Output is determined based on two things. First one is current input, and second one is past input in the past, 과거 input, right? How come? 과거 input is gone, right? Past input is already gone, right? So that means this sequential logic should have a capability of remembering past input, right? It's supposed to have some hardware component. This hardware component remembers past input. That is called flip-flop, right? Flip-flop remembers the past input. So output is determined based on current and this past. Okay, the data is stored. Okay, you can think of it as a memory component. It memorizes the past input. Okay, so output is determined based on current and past input. That is sequential logic. That is sequential logic. So the good news is, CPU is designed with the same, principle, combinational and sequential logic. The only difference is CPU takes instructions as an input. Okay, it is not, push button input, right? So in this, in this combination logic, you are taking this push button input, then output is determined. But CPU takes instructions as an input, then execute it. But CPU itself is designed with the same principle, with combination logic and sequential logic. That is good news, right? So by changing these instructions, okay, changing these instructions, that means by changing program, because program is collection of instruction and data. So by changing instructions, CPU can execute different programs. CPU has many different shapes. If you put Google Chrome program, Chrome instructions, compiled instruction, okay, Google Chrome, then CPU turns it into web browser. If you put MS Word, the program, right, instruction and data, then your computer turns into documentation tool. If you put MP3 player program into the memory, okay, that program is composed of instruction and data. Okay, then your computer turns into music player. Okay. So again, the difference between these two. CPU. What is so special about CPU? CPU takes instruction as an input, then execute it. Okay, that is the one. Okay. So any question about this? Okay. So this one, 한지상.
Other in computer. Computer architecture course mainly covers how to build a CPU with the basic elements.
Okay, thanks. This slide is also still comparing these two courses, digital logic design and computer architecture. The thing is, using the same principle you learned in digital logic design course, you can design CPU. You can design CPU. Not this complicated CPU. We are going to play with very simple, super simple CPU. Okay, because we are learning. Okay, first, time learner. So we are going to, use super simple CPU you can play with. Not this, Intel, complicated one. And another view of computer architecture class. Look at this. Okay, so here again, digital logic design course using combinational and sequential logic. You can design these too. You can design these toys, right? And last year, I think, okay, when you are a freshman, you studied C language, Java, Python, and so on, right? And computer architecture, this class is the place. Okay, this course is the place where software meets hardware. Again, computer architecture class, this class is the place where software meets hardware. Why is that? This CPU is still hardware, right? Still hardware. And that is designed with the same principle you learned in digital design, right? Same principle you learned here. Using combination logic, sequential logic, you can design CPU. You can design computer. And that computer is able to execute software. Okay, software. This CPU is able to execute program software, because software is simply what? Collection of instruction and data. And this guy, CPU, takes instruction as an input, execute it. It has a capability of executing instructions. Okay, so this class is the place where software meets hardware. Okay. Okay. This one, 정훈.
Yes. 모던 X 들리나요?
Yes.
Modern x86-based computers are very complicated. It is covered in advanced computer architecture course in graduate school. Our goal is to learn and understand the basic operation and mechanism of computers. So we focus on new, emerging, and simple CPU, 32-bit, RISC-V, memory hierarchy, cache, main memory, and hard disk.
Okay, thanks. In this class, we are not going to talk about your desktop CPU, notebook computer CPU. Okay, inside your notebook computer, desktop computer, there's Intel CPU or AMD, right? The reason why we don't talk about this because it is so complicated, super complicated. Okay, super complicated CPU. Okay, so that processor is normally studied in graduate school. So if you want to study Intel, your notebook, desktop, processor, then you can join graduate school. Okay. Instead, in this class, we are going to talk about super simple CPU, which is called RISC-V. Okay, RISC-V. It is emerging. RISC-V is emerging, processor. It was introduced 10 years ago from University of Berkeley, and it is gaining a lot of traction these days. There are some startup companies. Those companies are designing, manufacturing, selling, these processor. So that is commercially available. Commercially available, CPU. So it is good to know. I think it will be very popular in the future. So it is good to know about this CPU. And the good thing about this one is it's super simple. So anyone can design CPU, play with the CPU. Really simple. If you have some experience in CPU and digital logic design, it can be designed in one day, actually. I can design this CPU one day, just one day. Very simple. But the good news is once you understand one CPU completely, if you understand one simple CPU completely, and it is very straightforward to understand other CPU. So that means if you understand RISC-V CPU completely, then you can, it is very easy to understand Intel CPU. Very easy to understand the smartphone CPU, ARM also. Okay, so it is important to understand one CPU completely. Then the other things is very straightforward. Okay, so I told you two things, right? The first bullet CPU in this class, and second topic, memory component in the inside the computer, cache, memory, hard disk. Why do you have to have these different memory component in a computer? The answer is performance, because of performance. Okay, this one, Sujin and Sujin.
The objective of this course is to understand how computer works. First, how the code in high-level language is translated to machine code and gets executed in CPU. And second, learn machine language, assembly language, such as RISC-V instructions. And third, learn microarchitecture, CPU implementation. And fourth, learn memory hierarchy in computer. Register, cache, main memory, and hard disk. And the second objective is to design a CPU with Verilog HDL individual class project.
Okay, thanks. Those are topics we are going to study. First three bullets are about CPU. Okay, first three bullets about CPU, and the fourth bullet, that is memory component in computer, memory hierarchy. Okay, so first one is translation of the code. How the C program is translated, how your C program, right? Hello world program, the very first program you write, right? C program is translated into instruction and data. Who is translating program into instruction and data? Compiler, right? Compiler. You either use Visual Studio, compiler, Visual Studio, or GCC if you use, Linux, right? That compiler is translating high-level code. For example, C program, C code into, this instruction and data. So the translation of high-level code to the low-level code. This one, high-level code. C program high-level code to low-level code. Translation, and then we are going to study instructions, RISC-V instructions in detail. Then CPU design, the CPU design. That is called CPU structure. CPU internal structure is called microarchitecture. Okay, internal structure of CPU is called microarchitecture. Okay, some little bit, it's like a blueprint. Okay, some high level, structure. Okay, we'll talk about microarchitecture. Okay, again, 3 bullets are about CPU. Okay, instruction and implementation, and the last one, memory hierarchy. And you have a class project in this class. Okay, the class project is design RISC-V CPU using language, and that language is called Verilog HDL. HDL means what? Hardware description language. Hardware description language. It is describing what? Hardware. This language, using this language, you can describe hardware. Okay, using HDL, you can describe hardware. Then that description will be translated into AND gate, flip-flop, NOR gate, and so on. Okay, your description will be translated into all these different components. Okay, AND gate, OR gate, NAND gate, okay, flip-flop, and so on. Okay, so I assume you know Verilog HDL. Okay, grading policy. There are 2 exams, which is taking 65%, midterm 30%, final 35%. And there are several assignments which will be take 5% of the final grade, and term project, class project 30%. Okay, that is the hardware system you are going to use. This is the hardware system. Okay, we are going to use to test your CPU design. You are going to design CPU with your computer using the language. Okay, you are going to describe hardware using language. Then some computer tool will translate that description into this logic gate. Okay, then after that you can download your design into this the hardware component. Okay, so I'm going to distribute this board to you, I think after midterm exam, not now, after midterm exam. Okay, okay, so okay, and the last one, if you miss this class 3 times, you don't have to show up anymore. Okay, so little warning to you. Okay, please make sure you attend this online class. Your attendance is recorded automatically. That is a good mechanism, right? I don't have to check your attendance. The system is recording, right? So please make sure. Okay, and if you're late 2 times, 2 late show-ups will be counted as 1 absence. Okay, don't be late. Okay, don't be late. Okay. Oops. Okay, so little warning to you. Jiun, Jung-Jiun.
Okay.
Can you please?
Yes.
Can you please? Yes.
Yes. Don't take this class. Don't take this course if you don't know what the combinational and sequential logic is, what clock is, what latch and flip-flop are, finite state machine, Verilog HDL. Please take digital logic design next spring and come back.
Okay, thanks. A little warning to you. Essentially it says if you don't understand, if you don't know digital logic design, then this course will be a nightmare. Really, nightmare to you. Okay. Really, right? Class project will be super difficult if you don't know this, especially combination logic, sequential logic, flip-flop, and very low HDL. How to design? If you don't know how to design, these two, combinational sequential logic with HDL, very low HDL, super difficult. Every day will be pain, really, right? Nightmare to you. Okay, please don't. Warning to you, don't take this one. Okay, first take this one, then come back. But this one, the last slide today. Nada.
Expectations. You will have a lot of fun throughout this class, but it could take a lot of time to finish your term project. After successfully completing this course, you will have a lot of confidence in computers and how computer works.
Okay, so I can give you some promise. Okay, this class actually will be very fun if you are very serious. If you eager to know, if you are eager to know the CPU, really, then this class will be, super fun, really, very fun. But the thing is, it takes time, right? No free lunch, right? No pain, no pain, no gain, right? So it'll take a lot of time, but after finishing term project, after successfully finishing this course, you will have a lot of confidence in computer, really. You have a lot of confidence. You will get a lot of confidence in computer. If you are not confident in software programming, right? Some of you don't take, program. Sometimes when you run a program in the freshman year, last semester, what did you do? You wrote hello world program and compile it, right? And execute it. Computer shows you some output, hello world string, right? You write some sorting program, right? And compile it, you execute it. And computer magically gives you some, the output, right? But some people take it very easy, right? And no problem, right? Writing program, execute it, and get the output. But some of you are going through very difficult time because something is missing. How the computer is executing my program shows the output. How that is possible? If you don't understand the detail, probably software programming is not getting to you that easy. I think some of you, if you are logical, then probably you feel about I think you got that feeling, right? And this class will clarify everything you have you have in mind. You have right. So please take this class serious. Then you can achieve this. You can achieve, right? You can have a lot of confidence, really. That's the promise I can give you. But if you are not serious, you don't want to study, just take the credit, then this is not the course you want to take. Probably you want to take other courses, other architecture class, right? But again, if you are serious, I can help you a lot, and you get a lot of confidence in computer. I think that is it for today. Any question? Don't be shy. No, it is individual project. Class project is individual project. The term project.
Professor,
Yes.
can you hear me?
Yes.
Okay. So are the books gonna be? Can we purchase the book like online, or should we go to Korea University to get those?
Again, the book, it is being printed now. Sorry about that. It is being printed now. So the book will be available next week. Okay, I think in the bookstore and also online store. Okay, so yeah, I'll let you know next week, next Monday, the status. I'm pushing 홍릉과학출판사 a lot. Okay, so okay, sorry about that. But this book is, I think, in my opinion, because I wrote this book and trying to use easy language and friendly language to explain computer architecture. Probably good to use this book. Yeah. Okay. Any other questions? Do you think taking both? Okay. Both digital logic, computer architecture this semester now? It will be. I don't know. I don't know. It depends on you, right? It depends on you. Can you handle these two, workloads at the same time? I don't know. So after midterm exam, class project will start after midterm exam. Then I'm not sure digital logic design course, how it progress, how it goes. Verilog HDL, when do you learn Verilog HDL? After midterm exam? I don't know. So it all depends it's up to you, right? Any problem if you use Mego? I don't know, TA, Sangwon, can you answer that question? So what you have to do is, the bottom line is you should be able to install some tools like, we are going to use a lot of several different tools, right? Like this. You have to install, that is the first assignment actually. You have to install Cygwin, some Linux-like environment, and also cross compiler, right? Compiler is translating high-level code into machine code, right? The instructions, machine code or instructions. Okay. And then what? Then to do hardware design, you have to install this one, Quartus, this CAD tool, Quartus, and ModelSim. You have to first try to install those tools to see how computer if it is working okay, then that's okay. Okay. Attendance check method. Yes, Jongwon, system is recording. The system, the Blackboard system is recording your attendance. Okay, when you log on, that exact time, date and time will be recorded, right? I try to provide lecture this video, but I don't know, we have some limitation these days because everyone is uploading video, or so simply we don't have enough hard disk space. Okay, Blackboard. So I'll try to provide recorded video to you. Yeah, but we have some limitation. What is the difference between CPU processor, matter of instruction? Yes, for now, you can, yes, that is the one, Yongsop, x86 ARM. But the good news is there are several different CPUs, right? x86 ARM, MIPS, RISC-V. The instruction shape, instruction formats are different. Instruction formats are different, but they are providing very similar functionality. Okay, for example, Intel x86, it is providing addition instruction. Okay, ARM also providing addition instruction. RISC-V is providing addition instruction. Actually, that is those simple operation, arithmetic operation is is the every CPU is providing. Right? CPU is providing arithmetic operation, some logical operation, memory read. You have to load data, memory read operation, memory write operation, and so on. So even though CPU is providing all different instructions, their functions are very similar. So if you understand one CPU, that is why if you understand one CPU, then it is very easy to understand other CPUs because the function, instruction functions are very similar. Yongsub, is it answering your question? Should I bring and use my own laptop for midterm final exam? Laptop. If the exam is online, then you have to use your laptop. Right? In case of online exam, right? Can I use? I didn't learn Verilog from digital course because school. Yes, Yunso. Unfortunately, yes, it will be a nightmare if you don't understand digital logic. Really, it will be a pain every day. Really, you probably cannot sleep at night. Okay, very difficult. Stop by your office in person. Yeah, right. Today, Daniel. Now. Oh yes, yes, you can stop by. Yeah, I'll be here after class. You can come to my office. Yes, yes, Daniel, you can come to my office. Yes, 애기능 카페테리아, 애기능 생활관 320. Yes, that's correct. Any other questions? You can turn on your microphone and ask questions. Okay.
Professor,
Yes.
Maybe I missed it, but I heard that we were using like 32-bit CPU for our course. Like we're learning based on 32-bit, but would there be any problem if since the laptop I use is based on 64-bit? So
it has nothing. It has nothing to do with your computer configuration.
okay.
Okay.
Thank you.
Your desktop and notebook computer are all based on 64-bit. Intel, right? Intel AMD.
Yes.
Intel, right? Intel, AMD, notebook, desktop, or x86. It is now a 64-bit architecture, 64-bit CPU. But it has nothing to do with. It has nothing to do with the CPU we are going to study. RISC-V 32-bit. Okay, so don't worry about this. Okay, nothing. It has nothing. No relationship. Nothing to do with this. Right.
Thank you.
Okay. Any other questions? The follow-up question with digital logic. Sorry to bother, but it still be possible to do. I don't know. It is up to you. Chanu, it is up to you, really. I cannot say anything, actually. It all depends on your learning curve. I don't know. Learning curve, right? So, before the midterm exam, we are going to talk about RISC-V instructions, RISC-V or machine code, 기계어 or 명령어. So by the time we are not going to talk a lot about digital logic, okay, digital logic design. But after midterm exam, we will jump into digital logic. Okay, digital logic of this CPU. Okay, so depending on your progress, yeah, I don't know, Chanu. It is possible, but again, it's up to you. Any other questions? Can I get some recommended course to learn digital logic? Yeah, if you go to my class page, here, digital logic design, right? So click on this ID. It is asking some credential. ID is course registration number. ID is 코세 221. Password, same password, ESCA. So click on this, then 코세 221, same password, right? So here you have lecture slide, or lecture slide, combination logic, sequential logic, Velo HDL. That is what you have to know actually. Velo HDL. It is explaining the syntax, keyword, everything. So only 3 lecture slide. Okay. So you can use that course web page, course page. Any other questions? Okay, I guess that is it for today. Okay, that is it for today. I'll see you next Monday. Okay, bye. Thanks.